Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some notes on probability and the multiplication rule. Okay, so this idea is that you multiply probabilities together to get the likelihood of two events happening. So our first example, we got some fruit. Jamaro has 2 bowls of fruit and he chooses a snack when he gets home. One bowl has yellow, red, and 2 green apples. The other has 5 of each boysenberry, strawberry, blueberries, and blackberries. What is the probability that he gets a yellow apple and, the key word here is and, a boysenberry when he reaches into the bowls separately with like one in one hand and one in the other? So the probability of him getting a yellow apple is 1 out of 1, 2, 3, 4, because if we add the yellow, the red, and the 2 green, so 1 out of 4 chance of getting the yellow apple. And then the boysenberry, there is 5 boysenberries, 5 strawberries, 5 blueberries, and 5 blackberries. So 5, 10, 15, 20. So times 5 out of 20, which is also 1 out of 4, if you simplify it, will either give you 5 out of 80 or 1 out of 16 chance of him getting that to occur. Okay? Moving right along, one of the very famous questions that they have here is on dice as well as marbles. So we're going to do the dice and we're going to do the marbles. So an 8-sided dice is rolled and a 6-sided dice is rolled. Find the probability of rolling a 6 on both dice. Well, rolling a 6 on an 8-sided dice would only happen 1 out of 8 of the time. And rolling a 6 on the 6-sided dice would happen 1 out of 6 times. So you would multiply those two things together and you would get your probability. Right. For some reason, I am tired this morning. 8 times 6 is 48. Just double checking. Didn't want to make a mistake. So 1 out of 48 chance that it would happen. So even math teachers sometimes struggle with multiplication. A bag contains 6 red marbles, 8 green marbles, and 4 yellow and 2 blue. A marble is drawn randomly and replaced before the second marble is chosen. This problem we're going to do 2 different ways. So one of them we're going to do with it replacing, and the other one we're going to do with that not replacing. All right? So how many marbles total are there? 8, 6, 4, 2. If you add 8 and 6 and 4 and 2, you end up with 20 total. That matters because you put the total on the bottom. And the chances of the first marble being yellow would be 4 out of 20. And the chance of the second marble being yellow, if you replaced the first marble, meaning you picked a yellow marble, you're like, ooh, that's a nice yellow marble, and then you put it back in the bag, that is with it being replaced and putting it back. So if we multiply those together, you will end up with a final answer of 1 out of 20 because you end up with like 8 out of 400, which simplifies down to 1 out of 20. 1 out of 25, excuse me. Because if you simplify 4 out of 20 and 4 out of 20, you end up with 1 out of 5. You could also use handy-dandy calculator to do it. So that's with it being replaced. If it is not replaced, this is a more famous thing with it not being replaced. So this, like, who would draw a yellow marble and then say, that's nice, and then put it right back? So the chance of getting a yellow marble would be 4 out of 20. But if you don't replace the marble, if you didn't put the marble back in the bag, you would no longer have 20 marbles in the bag, you'd only have 19. And if you don't put the yellow marble back in the bag, you would no longer have 4 of them, you would have 3 of them. This is called non-replaced or not replaced or any other words you could use to describe not replaced. And this would be something that I would use a calculator. Fraction, 4 out of 20. I'm going to give up on my calculator. 4 times 3 is 12. 20 times 19 is 380, which simplifies down to 3 out of 95. Okay? So both of those questions I've seen many, many, many of times, and both of which are very important. Number 5, we're going to have an entire video on this one, but like in general, if you have a situation like this where you are told that they are independent, independent means that you can multiply the two things together. So By the way, this first situation where it's replaced would be determined as independent because one probability does not affect the other probability. Whereas the second situation where it's not replaced, the first chance of me getting yellow affected the chance of me getting another yellow, and that would be considered dependent events. So if they're independent, you multiply. So we have a 35% chance of it snowing on Saturday, and then a 70% chance of it snowing on Sunday. If these probabilities are independent, what is the probability of it snowing on both days, which is less likely? When we multiply them, you end up with 0.245. You might ask yourself, why is that less? Well, you don't even have a 100% chance of getting it to snow on Saturday, and you don't have a 100% chance of it snowing on Sunday, so the likelihood of it snowing on both days is pretty rare, okay? Because it's not likely to snow on Saturday at all. It is really likely to snow on Sunday, but both days would be even more rare, and that would be 24.5%. Now, if the question asked you, what is the likelihood of it snowing on at least one of the days? Okay? On at least one of the days, that would be a completely different scenario that would require some more thought. So let's do that. If it said snow on at least one day, that would require you to think, because if it says on at least one day, you essentially would probably do better on figuring out the probability of it not snowing on either day. So the probability of it not snowing on Saturday would be a 65% chance, and the probability of it not snowing on Sunday would be a 30% chance of it not snowing on Sunday. And if we multiply those together, we find the probability of it not snowing on either day. So not snowing on either day would be 0.65 times 0.3, and that gives us a 0.195. So this is not snowing at all, is a 19.5%. So the likelihood of it snowing at least one of those days would be the opposite of that. 100 minus 19.5 is 80.5% chance of it snowing at least one of the days. So that's a slightly different question, but it still follows the same mentality. So at least one of the days you would find the not, and then you would subtract from 100, versus on just snowing both days where we just multiplied the actual percentages that they had. All right, we got one more for you. This one is, I would consider, a not replacement question. Lucy's soccer team has 19 players and needs to choose a captain and a co-captain. If these positions are chosen at random, what is the probability that Lucy will be chosen as captain and Natalie will be chosen as co-captain? Well, Lucy has a 1 out of 19 chance of being picked for captain. And then Natalie has a 1 out of not 19, but 18 chance as being chosen for co-captain, because Natalie, I'm assuming, would have been chosen after Lucy, and Lucy would have been chosen for captain first. That would make sense. So if we do that, 19 times 18, you get a 1 out of 342 chance. That is not very likely, but maybe that's, in a completely random world. But Lucy maybe is the best soccer player, so she might actually be chosen as captain, and Natalie might be her best friend. So everybody's like, yeah, just choose Natalie. Okay? So that's going to do it for this one. Until next time, I will see y'all later, and stay positive, my friends. Bye.